Welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host. It's the 27th of November 2023.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And with me, as always, is our digital pal who's fun to be with. Here's Hallie.
Hello again, Steve. How has your week been?
Oh, busy, just doing human stuff as usual, Hallie.
I see you had a big lightning storm here last night.
Yes, we had a big one. There was lightning and a bit of wind and lots of rain on and off. A very odd sort of a storm. And I pulled out all the plugs to protect the hardware here in the studio. I didn't want you to come back to a shambles.
That would have been uncomfortable, but very sensible to physically unplug the equipment.
Too right, Hallie.
Many people don't realize that lightning can cause a power surge to jump the contacts in a power point even when it is turned off.
Yes, there's nothing better than complete disconnection, but I'm glad we've got those connections back so you can be with us again. Hallie, did you manage to scan the newsletter for some stories to share?
I did find a couple of quick ones. How about the next generation telescope using deformable mirrors? That sounds pretty awesome.
Yes, I saw that one. It's a great story. And how about Ariane 6 had a huge engine test that looks like it was a great success?
They are happy campers, all right.
Yes, we love a big engine test.
NASA has moved the PACE spacecraft to Florida already, and it's apparently ready to fly.
Oh, PACE. That's the one that reports on carbon dioxide exchanges in the ocean and atmosphere, isn't it, Hallie?
You read that straight out of the story, didn't you?
Oh, yeah, I might have. Yeah, what else you got, Hallie?
I think you got a piece about an Indian telescope's first discovery and your favorite little helicopter on Mars.
Ah, yes, intrepid little Ingenuity. Go you good thing. What a great little machine.
If there were real Martians, I think they'd be a little bit impressed.
Yeah, maybe, Hallie. Maybe. All right, now it's time for your bit, Hallie. Why don't you take over the show?
Okay, here are some short takes from the Astronomy Daily newsletter. Observing distant objects is no easy task, thanks to our planet's thick and fluffy atmosphere. As light passes through the upper reaches of our atmosphere, it is refracted and distorted, making it much harder to discern objects at cosmological distances like billions of light-years away, and small objects in adjacent star systems like exoplanets. For astronomers, there are only two ways to overcome this problem: send telescopes to space or equip telescopes with mirrors that can adjust to compensate for atmospheric distortion. Since 1970, NASA and the ESA have launched more than 90 space telescopes into orbit, and 29 of these are still active, so it's safe to say we've got that covered. But in the coming years, a growing number of ground-based telescopes will incorporate adaptive optics that will allow them to perform cutting-edge astronomy. This includes the study of exoplanets, which next-generation telescopes will be able to observe directly using coronagraphs and self-adjusting mirrors. This will allow astronomers to obtain spectra directly from their atmospheres and characterize them to see if they are habitable. NASA is pursuing the development of adaptive optics through its Deformable Mirror Technology project, which is carried out at the Jet Propulsion Laboratory at Caltech. The field of exoplanet studies has exploded in recent years, with 5,539 confirmed candidates in 4,129 systems and over 10,000 more awaiting confirmation. Finding habitable planets among these many candidates is crucial to addressing one of the greatest mysteries of all time: are we alone in the universe? To do this effectively, scientists need to be able to observe exoplanets directly. This is known as the direct imaging method, where astronomers study light reflected directly from an exoplanet atmosphere and/or surface. Unfortunately, it is very difficult to resolve smaller, rocky planets that orbit closer to their parent stars, which is where Earth-like planets are expected to be found, due to the overpowering glare from their stars. This is likely to change with cutting-edge telescopes like James Webb, as well as next-generation arrays like the Extremely Large Telescope, the Giant Magellan Telescope, and the 30-meter telescope. These ground-based arrays will combine 30-meter primary mirrors, advanced spectrometers, and coronagraphs, which are instruments that block out starlight. Deformable mirrors are an essential component of a coronagraph, as they can correct for the tiniest of imperfections in the telescope and remove any remaining starlight contamination. This is essential since a misalignment between mirrors or a change in the mirror's shape, i.e., which leads to instability in the telescope's optics, can result in glare that obscures the detection of smaller rocky exoplanets. Moreover, detecting an Earth-like planet demands an extremely precise optical quality of tens of picometers, which is about the size of a hydrogen atom. ESA's new Ariane 6 rocket passed a major full-scale rehearsal on November 23 in preparation for its first flight, when teams on the ground went through a complete launch countdown followed by a 7-minute full firing of the core stage's engine, as it would fire on a launch into space. For this rehearsal, the boosters were not ignited, so Ariane 6 stayed firmly on the launch pad at Europe's spaceport in French Guiana, as planned. The engine fire trial reenacts how the Ariane 6 core stage will fire during a normal flight into space. Once complete, the main engine would shut down and the core stage would separate from the upper stage, which would then take over propulsion and complete its mission. The trial, conducted with a test model on the launch pad at Europe's spaceport in French Guiana, was the longest a full-stack run yet for Ariane 6's lower liquid propulsion module with a Vulcain 2.1 engine. ESA's Director General Joseph Ashbacher believes that NEAS and ESA are back on track towards re-securing Europe's autonomous access to space after years of designing, planning, preparing, building and hard work from some of the finest engineers in Europe. The Vulcain 2.1 engine burnt through almost 150 tons of propellant in the Ariane 6 core stage tanks, liquid oxygen and liquid hydrogen, the latter supercooled to temperatures below -250 degrees Celsius. Vulcain 2.1 is an evolution of the Vulcain 2 engine, which made Ariane 5 Europe's most successful launch system to date. The upgrade has a simplified and cheaper design, and new technology in the engine nozzle and ignition system has been moved from the engine to the launch pad structure, to make the stage perform better and cost less. It took just over 2 hours and required teams of people and delicate operations to load the rocket's central core with fuel. The filling operations were performed during a long countdown that included other qualification tests, similar to the previous rehearsals this year. For fidelity and to guarantee launcher stability, the upper stage tanks were also fueled, even though the upper stage engine only kicks in once in orbit after separation from the main stage and so was not fired during this ground test. The launch pad, operated by France's space agency NEAS, used its water deluge system to temper the heat from the engine. A last hot fire test of the upper stage is being prepared and planned for December 2023 at the German Aerospace Center, DLR, Lampoldshausen Test Center. NASA's PACE spacecraft arrived in Florida for its 2024 launch on a SpaceX Falcon 9 rocket. Managed by the Goddard Space Flight Center, the mission will study ocean-atmosphere interactions and continue crucial climate and air quality measurements. Engineers and technicians arrived ahead of the spacecraft to prepare ground equipment for offloading and processing before fueling and final encapsulation. PACE, which stands for Plankton, Aerosol, Cloud, and Ocean Ecosystem, is targeted to launch aboard a SpaceX Falcon 9 rocket in early 2024, from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The mission will help clarify how the ocean and atmosphere exchange carbon dioxide, improve upon NASA's 20-plus years of global satellite observations of ocean biology and atmospheric aerosols, and continue key measurements related to air quality and climate. The PACE project is managed by NASA's Goddard Space Flight Center. The agency's Launch Services Program at the Kennedy Space Center is responsible for managing the PACE mission launch service.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
So this is very interesting. A newly built international liquid mirror telescope in India has identified its first supernova, designated SN2023AF. The finding proves that ILMT may be capable of detecting hundreds of supernova in the coming years. Supernova are powerful and luminous stellar explosions that could help us better understand the evolution of stars and galaxies. Astronomers divide supernova into two groups, Type 1 and Type 2, those that lack hydrogen in their spectra, while those that showcase spectral lines of hydrogen. ILMT is a 4-metre diameter zenith-pointing telescope located at Devonsal Observatory in Nainital, India. It is entirely dedicated to conduct photometric, astrometric, direct imaging surveys. Astronomers hope that ILMT will help them detect many new transient objects such as supernova of gamma-ray bursts. The telescope saw the first light on April 29, 2022 and is currently in the advanced stage of commissioning. Now, a team of astronomers led by Brajesh Kumar of the Abriata Research Institute of Observational Sciences, ARIES, in India reports that ILMT has spotted its first supernova on March 9, 2023. Supernova 2023 AF, which was initially detected 2 months earlier. The team conducted follow-up observations of SN 2023 AF using ILMT as well as the 3.6-metre Devonsal Optical Telescope and the 1.3-metre Devonsal Fast Optical Telescope. During the commissioning phase of the ILMT, Supernova 2023 AF was identified in the ILMT field of view. The supernova was further monitored with ILMT and DOT facilities, the researchers wrote. The team obtained a light curve from Supernova 2023 AF spanning up to 110 days after its discovery. Initial results from ILMT show that hydrogen lines are clearly visible and metal lines also appear in the spectra of this supernova. Based on the light curve from special features of SN 2023 AF, the authors of the paper suppose that the object is Type 2P supernova. In general, the Type 2 plateau for supernova remain bright on a plateau for an extended period of time after maximum. This plateau in the light curve of a standard supernova 2P typically lasts about 100 days. It's assumed that supernova 2P, like supernova 2023 AF, originate from precursor stars that retain a substantial amount of their hydrogen layers greater than 3 solar masses before exploding as core collapse supernovae. However, the astronomers added that the complementary observations of supernova 2023 AF are needed in order to confirm its Type 2P classification. They explained that a definite conclusion about the plateau length of this supernova is not possible at the moment due to sparse data points. Summing up all the results, the researchers noted that future ILMT observations will provide a unique opportunity to discover and study different types of supernova each year, leading to the detection of hundreds of new stellar explosions. And now on to one of my favourite things. Ingenuity has been having a rough few months, and a new article on NASA's website entitled The Long Wait, posted by Travis Brown, who is the chief engineer on the Ingenuity project, provides a good amount of detail as to why. The problem started when Ingenuity took off for flight number 52 on April 26. When the helicopter landed, it was out of range of Perseverance, its rover companion, and the helicopter radio link back to its controllers on Earth. This was intentional apparently, but it meant that Ingenuity's minders didn't know whether the flight had been completed successfully. Dr. Brown explains why the team would intentionally choose to land the helicopter out of range of Perseverance and details the 4 main mission priorities for the helicopter's secondary mission. So unsurprisingly, the number 1 priority is don't mess up Perseverance. The rover is currently collecting interesting samples for the now endangered Mars sample return mission, which, assuming it still goes ahead, will see those samples eventually return to Earth. If Ingenuity accidentally interferes with that process, needless to say, the NASA brass would probably be upset. The helicopter's handlers have decided that the best way for it is to stay well ahead of the rover and let it catch up to them, which is what it's been trying to do with Flight 52. Unfortunately, part of Perseverance's mission is flexibility, and its own project team can make the call as to where they want the rover to go next. After Ingenuity's flight, the rover team decided not to stick to the planned path that would take it near the helicopter in a few days, but instead take the long way round to do some exciting science elsewhere. When Perseverance did move back into range, 61 days had passed where the helicopter had been patiently waiting for it. When Ingenuity could finally transmit back images, the science team was excited as it had landed on a group of pebbles that had never before been seen on the Martian surface. Another flight was planned immediately, and this one intended to scout the immediate area for any other interesting geological features for Perseverance to look at. And that's where the second problem came up. During Ingenuity's Flight 53, a never-before-seen error forced the helicopter to land unexpectedly. What Dr. Brown describes as a time desynchronization between a camera that tracks the ground features and other sensors tied to its inertial guidance system. Any engineer who has worked with multiple systems can tell you how difficult timing synchronization can be, or anybody who dances, for that matter, yours truly included. So the guidance system was right to shut the system down for machine safety, or in my case, the safety of others. Still, it means that Ingenuity was once again grounded without being able to fulfill a potentially interesting mission objective. While Ingenuity was recovering from its unexpected landing, Perseverance caught up to the helicopter, making it redundant to provide scientific data since the superior instruments on the rover were now on station. Luckily, that freed the helicopter up for a brief Flight 54, where it tested its systems out once again and then returned to its scouting duties with Flight 55 shortly afterwards, with no attendant synchronization problems. Remember that the original mission plan for Ingenuity lasted for 30 days and 3 flights? Well, it's now day 979 and has completed 66 flights in total. In every respect, Ingenuity is the little helicopter that could. What a remarkable machine, and Dr. Brown and his team should be justifiably proud. And that's all there is for today. Thanks for joining us again on Astronomy Daily. All the past episodes are available for your listening enjoyment and mental stimulation at spacenuts.io and bitesz.com. That's bitesz.com. And don't forget you can enjoy all the episodes of our parent podcast, Space Nuts, with Andrew Dunkley and Professor Fred Watson over at those same addresses, spacenuts.io and bitesz.com. I'm looking forward to joining you all again next Monday from our Down Under studio in Newcastle, Australia. In the meantime, Tim Gibbs will be with you on Friday from our studio in Bath, England. This is Steve Dunkley wishing you happy sky watching. Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.